Hello and welcome to this tech talk. It's going to be covering database transactions and best practices. It's quite a vast topic, so I'll be only covering quite a little bit of all the complexities of it, but it's mostly related to mistakes that we do, and we've actually seen in our day-to-day code, and identifying issues with our misbehavior. Yes. So these are the topics that I'll be covering today, like the transaction itself, the annotation. I'm expecting that everyone, at least most of you, know how a transaction is used. So that's that. Then there's the isolation of a transaction, lazy loading problems, and the new Spring Data repositories that we've been implementing in our code recently. So let's start with our first example. This is quite an easy method. It loads an organization from the database and then getting a list of quotas by lazy loading, and then selecting just the first one and retrieving the node ID. Does anyone know if this works or not, or if there's any issues with this code? Anyone?
Probably you don't have a DOM function open here.
And
Initialization exception probably.
And that's what will happen. So we'll be encountering this error, which basically the lazy loading will fail because, of course, the transaction doesn't exist while we're doing the lazy loading. And that's...
Sorry, because there isn't the annotation.
You can say that there isn't an annotation. Basically, there's no transaction in that context where we're loading
the implied in Spring Data, the transaction.
Right, in the repository itself.
Yeah.
But once we're out of that method, which is defined one,
Okay.
the context, that's already finished. So now we're out of the transaction. So that's quite typical. I think, everyone encountered that error whenever we're using a database. So, and a possible solution would be, I think you already answered most of it. So adding a transaction on the method, right? So that would be our solution, and actually it would be an easy one, but that will work, but that's not, in most cases, that's not the ideal solution, to be honest. And this is where I want to actually start getting to know better why it would be not really an ideal solution. So this is hiding complexities and functionality. Now we'll deal into that later on. There's the possibility of reading stale data due to the isolation of the transaction. We can be having connection pool exhaustion, and also probably doing more queries than we intend to.
So why is connection pool exhaustion?
We'll go into that later on. So the isolation. Transactions are meant to live in isolation. There are variety of levels of isolation. Ideally, I'm not going through all the isolation levels today because every topic is quite vast in itself. But I'm going to give you an idea of the why it's important to know about it and at least figure out what's the best isolation, if it is. It's always required, but the default and what's necessary would differ from what we expect. So basically, the isolation is meant to be there so whenever you open a transaction, you've got your you're in isolation. You can work without anyone else affecting your data. So you can change your data as much as you want without anyone affecting that data while you're doing that. As I said, there is a variety, so sometimes they can affect each other. It depends on the level of isolation. So there's total isolation, and there's like another isolation which is quite lenient, and you can see changes of other transactions. So default for Spring is actually use the database, the actual physical database isolation level. In case of MySQL, it's a repeatable read, which we'll go and do it later on. So that's what we're using if we're using MySQL. Different databases use different isolation levels. So at least knowing what you're using.
Not like SQL, which tries this, no?
For Spring, yes. Because the default value is use whatever the database is using. So
for example, Hibernate also. It would be using the isolation
of the database. Yes, if you don't specify it. Default. So what we usually use, because we don't really specify it. So there's that, and of course, why is it a problem? As I said, you can be either reading stale data or might be reading actually having dirty reads, which is like being affected by other updates and what's not. So this is an example of two transactions on each side. There's a database in the middle. In this case, we're reading an organization logging count. So with the organization with ID 5, and we're reading logging count of 10. In the meantime, another transaction is reading that same data, and it's reading 10. So this is usually a race condition. The transaction 1 increments the logging count. So it sets it to 11, commits the transaction. The other one just does the same thing, and we're stuck at 11. Actually, that should have been 12. So how do we fix these kind of problems? Isolation, through isolation as well. I'm going to show you like the different isolation levels and if they actually fix our problem or not. So this is a repeatable read isolation level. This time I'm including each step actually more in detail. We're opening a transaction on each thread. So we're reading the logging count on thread 1, and we're reading 10. We're incrementing in the transaction, so we're not yet committing this time. So that's just living in the transaction context. While in the other transaction, we're reading a logging count of 10 as well, because the first transaction is not committed yet. So we're reading 10. Transaction 1 commits, and that's been updated to 11. If we read again on transaction 2, it would still give us 10, even if it's committed. So this in itself fixes quite some issues, but doesn't solve this current issue that we're saying here. Repeatable read is quite high in isolation level. So once you read a value, it will never change basically, even if it changed from another transaction. So even if the other transaction committed, the value stays the same because you've already read it in that transaction. If we didn't do the fifth step, which is the read from transaction 2, and we just read here, we would see the actual 11 value. But we read before the actual commit, so we read a value of 10, we read again, and that stays 10, no matter what. Like rollback or whatever in this thread, it will stay the same. So one thread is going to be repeated. That's why it's a repeatable read.
Are you talking about the post here?
Usually But then with the, I mean, this is mostly at the DB levels. So if you're working with a database level, unfortunately, if you're working with Hibernate, it's mostly transaction level on the same instance. So yeah, no, it doesn't, because the context for Hibernate cache level 1 is per session, level 2 is per instance.
So when you limit your session, no one has to make any changes in order to get there?
It depends on the isolation.
Yes.
That's why this is there. So this is MySQL's isolation level. So at least now you know that you're usually working with this type of mechanism. Then there's the read uncommitted. I'm gonna show you, like, I mean, it's good, but it's bad also in other ways. I mean, each of one of these isolation levels has a purpose, and of course, each of them has its own drawbacks, of course. So you have to identify which best to use if you really need something different than the default. So this time we're reading any uncommitted data as well. So it's not just committing and seeing an update, but actually whatever has been changed in another transaction is going to be reflected in ours. So this case, we're opening two transactions on two different threads. We're reading the login count as, again, it's 10. We're incrementing in transaction 1. This time we're reading quickly after the increment, and we can see the update. It's 11 on the transaction, on the second transaction. Now the problem lies if that rollbacks. We're still with that well, of course. I mean, if we don't read again, of course. But so each one of them, I'm just pointing out the issues, because I mean, now you know how it works, but of course there's that issue as well. I mean, the more isolated, the better the data, but you're still probably be reading stale data. So at least you know the differences, and how do we cope with these. We'll eventually come to it later on. So another way to actually deal with this is using locking reads. Of course, it entails locking. This is database logging. The JPA supports it as well. So, I mean, everything I'm mentioning means database, but JPA usually supports everything that we're saying. So, this time we're reading again the logging count, but we're reading it in a different method. We're reading it with a lock in mind. So we're saying, like, usually it's for MySQL it's a for update. We say, like, select whatever for update. Hibernate translates that. I think it's used through locks annotation, something like that. Then on the second thread, we're reading the same way, but that doesn't return. So it stays waiting, because of course there's another lock in progress from the first transaction. So then we're incrementing transaction 1, committing. Once that's committed, a return arrives on the second transaction, and that reads, of course, 11. And we can increment that commit doing the same action as transaction 1. And that gives us quite the actual data that we want to. Our intention was to actually increment the by 2 the logging count, and that way it's quite secure to actually do that. But of course, it entails locking. So if something is slow, you're gonna be locking quite some stuff. So, whenever using this, ideally you just read as in a locking way, update, and that's that. You kill the transaction. So you never lock for a long time. So these are the possible solutions. manage isolation levels, you have to identify which ones suits your job. There's the logging reads, and of course, opening the transaction as late as possible. This is gonna be probably the third option is gonna be visible in quite a lot of other solutions that we're gonna mention today because it affects quite a lot of things. Any questions so far?
This blocking isolation is that one that raises the exception of the need to log exception used by Hibernate. And there is a column that you can add on your entity called version, and every time you update that row, that version is increased.
Not sure.
And when you try to complete and your version is different, you get that exception.
I'm not sure. This is usually supported by the database itself. So this is an actual database log. I mean, the database supports the actual logging. I mean, whenever the database supports transactions, it usually supports logging as well.
You log the row.
If it supports row logging. For example, in Node B supports it, but my ISAM, which was the previous engine, doesn't. So but didn't support transactions as well. So that's why, I mean, once a database supports transactions, it usually supports row locking and everything. So let's pass to the next one. So connection pool exhaustion. So how can this happen? Basically, whenever we open an annotation transaction and we open the transaction itself, whatever is in that method, so if it takes 1, 2, 5, 30 seconds, basically hogging that transaction for 30 seconds. Because until that method finishes, basically I use connection. So if you've got 10, basically you're saying, and you've got a 30-second process, you're saying that you can have 10 requests every 30 seconds, or else your application dies. That's just a simple example of how it can happen. Pool ideal size.
So let's say, for example, in the example you showed us, where we were calling the repository and then make those companies using the Mysql. If there has to be separate transaction, if we had you added the actual transaction on the method, so we're going to have one transaction for both.
For both queries.
Why would it be better if they each had their separate transaction?
If it's that simple, it wouldn't matter.
Okay.
That's why now we're going to delve into like why it wouldn't be best solution or not. We're just saying like if there's something in between that can take longer, it's a problem. So that's why we're gonna build up now.
Update the database.
Yeah. But sometimes it's needed. So that's why we have to deal with like how we have to maybe change our logic to actually deal with these problems. But that was
the biggest issue that we sometimes see is, for example, there at the business layer, you call the persistent, you call a persistent method, you return the model object and expose it as a business layer, then you do a lazy loading on something after you close the transaction from the business layer, and later on you end up without the transaction. So it is sometimes common that we see a transaction method on a business logic. So of course that means you're going down the persistence layer, the transaction, going out of it, but of course you always have an outer spend. You're spending the transaction upwards. So the transaction you're leaving it for always longer, so if you have concurrent requests, you're always increasing the number of concurrent connections.
Yeah, but the issue is that then the time spent on the transaction is going to be the same. Spent on the actual query is going to be the same. The issue is that there might be logic in between, which has nothing to do with the database, but you're actually locking the transaction.
So if it was the previous example, it would be fine. But doing so, the idea is, if there's a problem like that, and the solution is at transaction immediately, think about it. Like, check that method, see what's doing, and then maybe edit. So that's not your go-to solution. That's what I really want to make a point on, because that might not be the solution. So let's see. So we were actually talking about the pool ideal size. So the database supports a lot of queries per second. As you most know, it's like in the thousands. That's queries per second. So different databases support different numbers, but anyway, it's quite fast. The thing is, our queries, if they are optimized to actually deal with that much queries per second or not. Like if the query is a slow query, it's not gonna be doing that same query for 1,000 a second. So, so ideally, queries must be good so that they perform better, and having a large pool size isn't ideal. In the end, the database sits on a physical computer, has a set amount of cores and threads, so in the end it will never work in parallel on a 30 threads at the same time, because it can't. Of course, it has to solve, like, it's sharing the process. And so ideally you don't have a really large connection pool, but actually improve your queries. So if there's a problem and that you don't have enough query connections, most probably your code is really not optimized. So just to show you an example, this is the same method, most of the time the same method, this time with a transaction up at the top, like our solution. We're again loading the organization, this time doing a slow call, just taking 30 seconds, using the data that we loaded from the database. That's why we queried the organization, because we need information from there. Then we're doing something, whatever, and then saving the organization or doing something else with the organization. So we need it all through the 3 calls. So that's basically holding the connection for 30 seconds. Basically, if we have a connection pool of 10, as we said before, we only support 10 connections 30 seconds. That's really not ideal. Whatever. I mean, if we have high loads, that's just not the way to go. Another example. This time we just removed the transaction up at the top. We queried the organization. So there was a transaction, it was opened, read the organization. It finished, we read an ID from the model. So we're not doing lazy loading there. We're just reading like whatever fields we just required. And then after those 30 seconds, we just reopened another transaction, did whatever we had to do. Don't mind the variables, it's just that we're just passing again another object or another whatever needs to be in there. We're just reloading if we need be, because of course it will be detached, so we can't use the same object. Okay, so in that case we'll be reading again, then changing whatever we need to change, and then updating. That way we're increasing the amount of queries, because we're kind of reading again, but of course we're not hogging the transaction for 30 seconds. So it's faster. I mean, we're not spending 30 seconds with an idle transaction, but we're increasing the amount of transactions. I mean, as we said, if the queries are fast and they perform well, you don't care. I mean, that's what the database is for. So just do it. It's much better than having a transaction hog for 30 seconds. So that's one way to treat it. This is, as we talked before, open a transaction as late as possible. It's here again. transactions are mostly for modifications. So if you're not dealing with modifications, you really don't need to open a transaction up at the top layer and stay lazy loading everything. You really don't need it. Now we're gonna see why and how we can deal with lazy loading without a transaction. So connection pool size, you should set it as, small as possible, but of course, code has to be efficient. You can't have one without the other, and you can deal with them as well with short timeouts. If something happens and the transaction gets stuck or something, what do you do? In the end, you can just time out quite fast. If your queries are fast, you can say like, my timeout will be 5 seconds. There's no query that will take more than 5 seconds. It shouldn't, to be honest, but anyway. But we don't set these things, so it's usually 30 or 1 minute. That's cause for trouble, basically. So
Was that not touched when
having 50 and doing 50 different queries at the same time is slower than being sequential on 6, or maybe let's say it's enough for the physical hardware like the CPU, to handle them on as much threads as he can, then overloading it with multiple that he will be sharing his time to actually handle the different queries.
probably also forces you to actually optimize.
The difference is minor, but of course if you're starting to getting a lot of load, these things will start affecting you quite hard. So, maybe PNCP isn't really the best case scenario, but maybe we've got other systems which get loaded and are affected without even knowing. All right. So let's talk about more queries than expected. Does anyone count the number of queries that we do in a method, or no one cares? Because actually it's usually not visible, so who cares? Anyone? No? Okay. That's usually quite a lot. They're always mostly sequential. Each transaction going over the wire takes time. As we said, the database is quite efficient, but the thing is we have to send data every time and expecting data, coming back, then parsing it, blah, 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 and that's taking time. So let's see. This time. So we're opening a transaction, we've got a loading of an organization, so that's one query. Then we're loading all the quotas, so we're retrieving 3 this time, but it's one query, but we're loading 3 results. Then of course for each, we're doing 3 queries and loading each quota event in this case. So we've got 3. If we want to load another table in that final for loop, it's gonna be 3 more. So this starts summing up quite a lot of queries. You don't have an idea, but this takes 100 milliseconds, which is okay, it's quite fast. But if you want to query something, 100 milliseconds is barely the limit to actually see a page instant loading. And this is just going there and coming back with data, not doing anything else. So in a real case, the page after this one, and if you're doing some JavaScript or if you're doing something else, it's not an instant load, basically. And we're not really doing anything here. We're just like reading information and just passing it through. Of course, if the data changes, if instead of 3 records there would be 10, it's going to be slow. And so on and so forth. So what do we do? If we do an eager load this time instead of a lazy load, So in that method, in the file1 eager load, I just joined the tables that I needed. So it's kind of custom for that particular case. Whatever I need, so the organization quotas and organization events are loaded. So that organization object and all quotas and all events are loaded, they're in memory. So with one call, I just got everything I need. And whenever I'm looping through, I'm just looping in memory. That took 50 milliseconds. So as you can see, I mean, we still had to parse all the data because it has the same amount of data. Although then we just went once, came back once, and then everything else is being done in memory. Data will not affect the amount of queries. So if it will slow down, it will slow down by a fraction of the time via the other solution. So it's quite a simple change. Of course, you'll have to just write your own queries. So that's that. Any questions?
Yeah, I have. So say that when it's good use the AT something. So say that apparently looks like it's always prompt.
Of course, it depends how performant you want your application. Is 100 milliseconds good for you? If it's good, you don't care. But if you want something that you know that you're gonna hit quite frequently and you want it to be like instant loading, like front pages or whatever, or you want actually, maybe it's not just a read, it's part of an update as well, and you want it to be available to actually have a high load, you just need it as performant as possible. So what do you choose? That's what your application is required to do. So that's the idea. I mean, yes, this performs better, but of course I had to do some code myself, I mean, it's just writing a query, but still, it took me, some extra minutes. But should you go there, is how bad is your application? Like, is it really slow? Is it bad? The thing is, you do one method and it's 100 milliseconds. Then, of course, it's part of another 5 calls, and then all of a sudden you're like looking at a 1 second call. If you start at the stage and you start adding up, at least you will not end up at 5 seconds, you probably end up at 2 seconds. So it depends. I mean, we always start with something small. We start coding, keep growing, implementing other stuff, and our system all of a sudden is really slow. That's what it usually happens. I mean, we've seen it over and over. So is it worth it to spend 1 more minute, or I don't know, maybe let's say half an hour to actually test the new query and everything? It depends.
The same thing can be done with model objects, of course. So if sometimes, for example, you have a case where keep your database normalized, you separate an entity into tables, for example, but then they are so closely related that in the model, whenever you read one, you're pretty much going to be reading the other. So pretty much you can, in the relationship, you can pretty much export eager version for that particular relationship. So pretty much
it's good to normalize, and the database, I mean, it's a relational database. It's meant to be. I mean, joins are super efficient. It's more efficient than lazy loading, of course. But then it's up to you. I mean, if it's really related, as Clayton said, make it always eagerly loaded in the model instead of just lazy loaded. Because you will always probably need it, but it depends. It's just.
Of course, you have to be very extra cautious then when you have relationships which are both ways, because you'll end up with the overflow. Like, for example, you have an order which is linked to a user, and from the order it can identify the user and vice versa. You do eager fetching in those, you're going to end up with a sub overflow.
But the eager loading actually does another query, not join, if I'm not wrong.
Okay, but it's two entities so closely related that actually when you read one, you can
way to join other DOMs.
Yes, of course. Some of them no, but so possible solutions. I mean, these are not set in stone, as we're saying. We're just building up on what might be problems and what not. So choose your options carefully. Of course, I mean, it depends what your application is intended to do. So in this case of slowness, avoid lazy loading, formulate your own queries, use joins, use fetches, and Hibernate initializers. These are all options that you can use, like how they can be used with all developers. So just look for them. I'm reiterating as well here, like weigh your options, of course. There's metrics, there's Hibernate, log. It will give you amount of queries, time to open connections, time to actually waiting. There's a bunch of statistics that you can get from the Hibernate logs and the enable statistics in Hibernate. So it's basically up to you. If you have time to actually analyze the metrics and you want something better, you've got the tools. Hibernate has them, so they're free. I mean, they're there. Just use them, basically. There's nothing extra. It's quite easy to do.
Logging the metrics, right? We're logging the metrics.
Sometimes we're logging, but we're usually disabling statistics on live. Maybe on dev we're enabling them, but on live we're usually disabling statistics. But for dev, I'm not sure. But for dev, yes, that's how it should be, because it slows down a bit. Another question? All right. So we're nearly there.
We push to log. If we're logging but on live now. So I was thinking if we're pushing statistics to
the logs they can be still logged, statistics log, but if there's no enabled statistics from Hibernate, it wouldn't still log the statistics. Yes, the package is being logged, but there's no statistics being gathered, basically. So,
but if we're pushing those to logging, then we can actually have alerts.
Yes.
So you're saying to check the metrics of how to use your query, we enabled from the logs Hibernate logging, and they provided the amount of milliseconds, for example.
No, I haven't pasted here. I mean, an image of the actual log, but the statistics log. I mean, you can log the actual queries done, so you can identify easily how much queries are there in one method. But also at the end of every transaction, it can tell you kind of a summary, like 7 transactions executed in this much time, and I spent this much time waiting for the connection to be open. So you'd actually know exactly like how much it took to open the transaction, to actually acquire. There's the pool, so they're most of the time always open. But and you can figure out like, okay, so the slowness is actually the query and not maybe something else. So it's quite a good summary. Even just that, at least you'll figure out how much queries you did in just one transaction, and like the metrics for them. So at least you know, okay, on average I did 7 transactions in 1 second each, because it took me 7 seconds, for example. So that's that. And that's enabled by the flag Hibernate. It's enable Hibernate transactions and enabling the logs, of course. So, all right. So using Spring Data repositories, which is nowadays quite a common standard. I think everyone or most of you have used these. We're just declaring interfaces and everything else is implemented by Spring Data. The thing is, if you're working and you want transactions to work, you have to disable the default transactions of Spring Data. Without this disable, which is an example in here, you will not be having whatever we just talked about. I mean, even if you're declaring a transaction beforehand, I mean, this lives in an extended context, and that only lives whenever the implementation exists until it finishes. And there's an annotation there. It's a read-only transaction. So any read, write, and everything else exists just in that implementation of that method. So the find one will just give you that method basically. And updates and whatever, they're gonna be committed exactly as soon as you do a save method. So even if the transaction fails, an outer transaction fails, it will not be rolled back. So make sure to disable the transactions. And
so this takes precedence over the annotation.
It is an annotation.
So the one that we define.
It takes over, yes. It takes over because it exists in an extended context. So the annotation of Spring, usually there's the propagation, which I haven't really gone into in these slides. If there's a S transaction in a method and there's another S transaction in another inner method, if there's no extra, it's the default, it's usually propagated. So whatever you're declaring up at the top is usually propagated. And it's gonna use the outer or whatever the caller transaction. But in this case, in the actual implementation of the repository, it lives in an extended context, and that basically the transaction starts whenever that is created until it finishes. So of course, it doesn't take into consideration anything else. It just starts with a transaction because there's an annotation, a transaction, and it's read-only. So it starts with that, does its own thing, the implementation, which is the read or the save or whatever we use. And as it ends, it just commits. So just make sure that that flag is there, or you won't be working with whatever transactions you might be thinking that you're working. We had this issue, I mean, so we dealt with it this way. I think that's it for this. I mean, I don't know if anyone encountered this issue except us, but anyone worked with JPAs or anyone pay?
Can you repeat again, David, what transaction manager is available by default and which one do you enable when you actually disable the default one?
What do you mean?
As in, like, you disable the, when you specify that flag of disabling the default.
So what we disable here is the actual transaction of the JPA repository. Basically, I mean, we usually declare interfaces method, so we leave Spring Data to actually do the implementation for us. So we don't really declare how the find one or whatever find many behave, and Spring Data will use its simple JPA repository implementation to actually wire that in. That the actual implementation has a transaction on it, and that's basically where all the problem relies, basically. Although it's a linear method where we are calling it, even if we declare our transaction in our code, it is not propagated as we always imagine, basically. So what we're disabling there is actually that transaction, so it doesn't take over our declared as transaction annotations that we declare in our code, basically.
But is this a matter of having a method a higher level message with an transaction, but which calls another message which has a transaction in it.
That's why, because the extended persistent context only exists whenever the class exists and it ends as it ends. So that's why it commits after that. So we end up with code that's already committed, but then we want to roll back, for example. So imagine if we do a method like we did, let me search, like this one, for example. There's a transactional at the top, so we're expecting that we do a find one, we query the organization, we do something with that, which takes 30 seconds. We do a save, then after, or we do a save, and after that we want to roll back the transaction, because hey, maybe something else that I wanted to do failed. So after that save, imagine there's something which should fail. With that save there, it's going to be committed at the end. So if we roll back the transaction, data will remain there. So
if you were doing find one there in the first query, so that's the save.
Exactly. If it was a save, that's committed. That's it. So even if there's the transaction is there. So that's basically the example that's quite a clear example. I don't know if anyone is. So yeah, whatever we were talking about, without that flag, it's basically you're not really working as intended. Basically, you think that you're using your transactions because it seems that it works until you start encountering rollbacks, but data would remain there. And probably that's the only way to actually find out. So that's that. I think that's it. A bit earlier. Alright, so we just skimmed some of the transactions today. I haven't gone into detail in each one, as you've noticed. The thing is, I just want you to have an idea that whenever you just declare a method that's transactional, see what's in that method. It's not always easiest. It's most of the time always the easiest, but not the ideal. So just think about it. Maybe refer to this one. Search your options. Talk to me. Whatever. It's there. If you want future presentations, just let me know. Maybe we'll go into detail in some of them. It's your choice. So, anything else?
Maybe like the default transaction actually hides a lot of the complexity. Because, for example, think about forgetting to annotate the message with a transaction. Of course, you'll see the transaction. So you're getting the repository.
If you're calling the repository, if you're calling the repository,
Yeah, it will show if you're doing lazy loading, but if you're not, for example, you're still opening a connection because Hibernate requires that, but it's not visible. That's why.
Or that other thing of smoking the transaction, for example, if you're not actually defining a transaction, but you're leaving it to the repository. But of course, then it's used to hiding the complexity, not actually.
That's why hiding the complexity is one of the issues of just declaring a method as transactional, and you're good to go, but what's happening in the background, as we said, depends on the method that you're annotating.
Is it possible that the developer see that disable the default transaction in a centralized point, such as maybe
I think this is better, because this is only available on this annotation. So whenever we're enabling the JPA repository for a certain package, and that changes per project, in this case it's VM backup, you'll have to define it there. I know it's not the best solution. I'd like to actually have it up at the top, but I don't think there's a centralized solution.
You can't do the base package, for example, compile
You can, but then you'll be enabling JPA repositories for what? For everything, or
Even if a wildcard in the middle, for example.
yes, like whatever, and we declare it up at the top, maybe.
You connect with the market by adding a custom annotation, but you're not forcing anyone to actually use your custom annotation.
No, custom annotations are, yeah, that's right. We still ended up with like, hey, someone has to actually do the custom annotation and not the JPA annotation. So you need to know that actually that exists and you have to disable it. So either that or, as we said, maybe a generic wildcard, but I don't know the ideal solution as well. Because then it's like enabling by default the repositories. So that's that. That's it. That's it.
Thank you, Xavier.
Thank you, man.
Thank you.
Bye.